Today I want to talk about a few things. Those topics are Webpack, Babel, and like a Webpack development server. We're going to figure out how to get that up and running. And so these things are what we would call like part of the tooling of the kind of modern JavaScript ecosystem. The idea is it's not really like the logic of our code or our code base, but it's some of the tools that we're going to use to actually get it up and running in the way that we expect. So the first thing I want to look at is just take a look at this code right here on the screen. We're seeing that we have some console log statements, and they rely on this function called square. So it says 3 squared is, and then whatever the return value of square of 3 is. That function square is actually defined in this other file over here. It takes in a number as an argument, returns that number times itself. Okay, so I want everyone to think about for a moment what we would need to get this code to run as expected. To say 3 squared is 9, 4 squared is 16, 5 squared is 25. How are we going to have this file know about the code in this file, given what we've learned about JavaScript so far? So take a minute to try to think about that and figure out how we would do this. Okay, so the answer is the only way we've kind of seen different JavaScript files be kind of included or required into each other thus far is through an HTML file. So in this HTML file is where we would write these script tags that say, hey, go grab this JavaScript file that lives somewhere else. So we've been loading all our files up via like a single HTML document, and it's there that we're getting everything. So there's a couple downsides to this. One is that this code isn't actually going to work as expected right here. Let's open this up in the browser. I'm actually not going to see a console log. I'm going to see this error. Square is not defined. That's because I messed up the order of these things. This index.js file, which is going to be read in first right here, actually depends on this square function. So I need to be sure that I'm going to write this above. Save, refresh. Okay, now we see the console log as expected. So that's one problem with loading in a lot of files through the index.html, is that it's kind of annoying to remember what goes in what order, and we can really imagine as our application grows and we have a more kind of complex set of dependencies that this file is dependent on this, that's going to be difficult to manage. The second kind of problem with loading up a lot of files through your index.html is actually a performance issue. So this is the network tab of 2 different web pages. If you notice, this is just all the JavaScript requests that we grab when the web page loads. So this is a ton of JavaScript. If I could scroll down, you'd even see more things scrolling down here. It is easier for your browser to go make one request and go grab some file that's very big than it is to make all these requests, and even if the files are smaller, there's all these different files. So it's actually, here's a website that sort of handles this a little more responsibly. This is the Instagram web app, I believe. But so they just have a few JavaScript files. And those files may be a little larger, but there's just a few of them, which is actually more sort of performant for the browser. So we can imagine Instagram's code base is probably very big. But they have just a few JavaScript files right here, probably even less files than one of our very small projects has. So how are they doing that? This is the point of Webpack. So Webpack is made to combine all your JavaScript files into one file, which we'll generally call our bundle. So it's going to take all these JavaScript files together, put them together into a bundle, and then our website can just serve up this one file called the bundle. Generally we'll call it bundle.js, just kind of as a convention. And it will be easier to manage those dependencies, right? I can go ahead and add more files to my project later, and it grows. I don't need to worry about the order of these things because Webpack is going to sort of handle that when it creates the bundle, as well as my site will be more performant. It's only loading up this one thing. Cool. So that's kind of why we use Webpack. Let's, in a second, we'll move to a kind of more real application than this kind of silly square example and talk about kind of how to implement Webpack in a more real application. See you in 1 second. So far in this course, all the JavaScript code we've been running has been running in the browser environment. That means there's certain global variables that are around, that such as the document or the window that our code kind of expects to be dependent on, and we've only really ran JavaScript in the browser. If anyone has ever heard of Node before, that's JavaScript running in an environment that is not the browser. That's what allows us to use JavaScript as a server-side language, and there's JavaScript web frameworks the same way we have Rails and Sinatra and Ruby, and those are running in Node. So Node does have what's called a module system. The one they use is called CommonJS. That actually does allow us to actually require in files, very similar to how we've done in Ruby in the past. We're going to talk a little bit about CommonJS, and then we're going to move on to the ES 2015 syntax. This is kind of more conventional in web applications, and we'll see this a lot more going forward. But let's just talk a little bit about this CommonJS module system. So if we look at our code, we should be able to, in this index.js file, we care about the code defined over here. So we kind of want to require in this here. I'm going to write var square is equal to require. I'm going to give it a relative path /square. I can leave off the extension .js because it just is assuming that we're grabbing JavaScript files. So this is saying whatever's in this file, store it in this variable called square, and now we'll go ahead and be able to use this variable. There's one more thing that we have to do in square.js. We actually have to tell it what we care about this file exporting. So when we say require this file, what are we going to grab for this file? What's important? So we need to say module.exports is equal to this function square. Cool. So in theory, this should work now. We should be able to get this code working somehow or other. The problem is we can't run it through our index.html file. It's not the browser environment that understands this module system of require and module.exports. It's actually the Node environment. So when we run Webpack, Webpack is actually running in the Node.js environment. So it's going to run. We should be able to use Webpack to kind of combine these files together and sort of see. We want to kind of explore what this looks like a little bit. Cool. So the next step is we're going to be talking about actually getting this set up a little bit. The first thing I need to do is run a command called npm init. This is going to give us a package.json file, which is really, really similar to if you're coming from Rails to our gem file. It's going to list out, hey, here's all the dependencies. This project depends on the different packages. You know, those are the equivalent of Ruby gems. It's going to tell us some information about a project and all that kind of data. So I'm going to run npm init. It's going to ask me a whole bunch of questions. I actually don't care about any of the answer to these questions. So I'm just going to press enter, 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 go through. Cool. And if we look at what this did, let's go to our project. We see this created this package.json file with some kind of like defaults in here. Let's look at this scripts key for the moment. So inside of this is an object. We give a key value pair. And so let's call something called log. And then this is going to say, run the command echo. I'm going to escape my quote characters. And inside of here, let's put hello. And save. So now I can go here. I save that file. I can say npm run, and then whatever the key of that script tag is. So npm log will print out hello as we see here. So we'll be able to, this is kind of a useless command, but we'll be able to use this in the future to actually kind of like run different commands we want. We can give different key value pairs in here and say npm run and different things. So the first thing I want to do is I want to install Webpack. So I'm going to say npm install -- save dev Webpack. So I'm specifically saying save dev. We'll see in a second. That's going to save it to the development portion of my package.json as just saving it to the general portion. This is just like in Rails how you have like the different kind of groups in your gem file. You have production, you have development, you have test. So let's run this code. This is going to go download this file. Give this a moment. Let's take a look at the changes that command made in our project. So we see here now we have a section called dev dependencies. These are the dependencies of our project for our development environment. And we see we have Webpack and the certain version of that. So what I want to do is actually, let's make a script called build. And what this should do is run the command Webpack. Now you might say that's pretty simple. Why don't we just run Webpack from the terminal? And that's a great question. If we run Webpack from the terminal, it's going to run any globally installed version of Webpack we have. But we want to be like, you know, the version might matter, the version might change. So we want to be actually, let's run the version of Webpack that's actually specific to this file. We'll see here when we ran that, it actually made this folder called node modules, which has all the different modules this is depending on, all the different packages this is depending on. It looks like there's a lot of packages here. Yet here in my dev dependency section, it looks like I only see one. That's because these are all dependencies of Webpack, and it looks like there's a lot of them. We can see here in our package.json that all the dependencies that Webpack has. Cool. Now that I have this build script, which will run the command Webpack, I'm going to go ahead and try to run it. So I'm going to say npm run build, and we should see an error. No configuration file found. A configuration file could be named webpack.config.js. So we need to do exactly what they told us. We need to set up this Webpack configuration file that's going to tell Webpack kind of like some rules about what it should do when it tries to run. So let's go ahead and touch a file called exactly this right here, webpack.config.js. All right, let's look at our project. Let's go here. And so what we're going to do is we're going to make a big object called config. It's going to have a bunch of key value pairs and will tell us all the stuff we need to worry about for the configuration of Webpack. And then we're going to be sure to export this at the bottom. Module.exports equals config. Okay, so there's basically two main properties for like the kind of bare minimum that Webpack needs to know about to be able to run. The first property is what's called the entry. This is kind of like the starting point of the application, where to look as the file that's going to requires all the other dependencies and kick everything off. In this example, it's going to be our index.js file. And this is pretty conventional. Generally, it's going to be, we're going to have some index.js file that is going to include everything else. So I'm going to go here and entry. This takes a relative path. So it should be something like ./index.js. Okay, great. The second property, we tell Webpack where to start. We need to tell it, hey, after you build and combine all these files, we actually need to tell you where to sort of output our bundle, where to put all this stuff together. So we're going to make a key called output, which is actually going to point to an object. Inside of the object, there's two properties we need to tell it, the path and the file name. The second one, file name, is going to be the file name. You combine all these files together, put these things in a new file. Generally, we'll call this bundle.js. Super conventional to call it that. Now we need to tell it here the path where we want this file to go. So to do that, just to take care of some different computers, different systems, we're actually going to import this thing from Node. So I'm going to say const path is equal to require path. This is built into Node. Remember that we run Webpack, it's running the Node environment. That's just going to allow us to actually get the whole path for our computer. Unlike entry, where it's a relative path, this actually needs to be an absolute path. So we're going to call on this path library that we reported. We're going to call a method on it, .resolve. We're going to pass in __ dir name for directory name, meaning the name of the current directory, and say let's make a folder called build /build after the whole current directory. So a little bit of confusion here. We could imagine kind of hard coding this in or writing this in different ways. Doing it in this kind of way will just stop any problems in the future of if someone tries to run this on a Windows computer or different computers or remove the files. It's just going to say go grab the full absolute path of whatever the current directory is, and then a build directory, and then we have this here, file name bundle.js. Cool. So that should be all we need for a basic Webpack configuration. Let's try to run this code again and see what happens. npm run build. Great. So here's our two files that are index.js, square.js. Let's go look back here. We'll see that what actually happened was it made this directory called build. Inside of it is this bundle.js. And there's a lot of code here. We're seeing all this code going on. It's a lot of code. But if we scroll all the way down to the bottom, we should see somewhere in here sort of the code we wrote. So here's the one file. We have this array right here, which is all our different files, array at 0, array at 1. These are the different files we could have. We see that it kind of changed our require statement to this Webpack require, which is all defined up here, and made this file bundle.js. Great. Next, I want to take some of the stuff we just learned and actually apply it to more like a real project, to a web application. So I have this Zookeeper app that we built in class. This is some JavaScript files and an index.html file. There's a Rails backend that we're hitting, so when we create a new animal, so we'll say Charlie is a male, a female, chimpanzee, and we go ahead and save, we should see this get added to the front-end application here, as well as we just actually went ahead and persisted this thing in our database. So I have that code up right here, and we'll see, here's our index.html file. There are three main files that we're using: index.js, api.js, and animal.js. So let's go we're going to go through the steps that we just went through of running npm init, getting the Webpack package in there, and do that basic setup that we just did. So I go here, we're here in this Zookeeper app. So I'm going to run npm init. I'm going to press enter, 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 enter a bunch of times in a row. I'm going to say npm install -- save dev Webpack. And while it's installing, I'll go ahead and add the build script to my package.json, as well as kind of bring in that default kind of Webpack config that we had from the other project. So see you in 1 second. Great. So I have this set up very similar to how we set up in the previous example. The only thing I changed was this, instead of being ./index.js, is now our index.js lives inside of this src or source directory. So that's actually, I just changed this relative pather here to ./src/index.js. So now if we run npm run build as before, npm run build, this should work. We should see that it actually created this build directory. We have this bundle.js, which here is our code from the code that's currently in our index.js. So if I go to my index.html and I try to replace these script tags with just a single one, build/bundle.js, and let's get rid of these. This isn't totally going to work yet. Go here to Chrome, refresh, we don't see anything, we're going to get a bunch of errors in the console, API is not defined. That's because we haven't told our index.js what other files to require in, nor have we told our animal file and our API file what to export, or what to, kind of like when someone requires in this file, what should they be requiring in. So we're going to do the same thing here as we did before, but we're going to use the ES2015 module system. You'll see it a lot more, and this is kind of what I would kind of want you to get familiar with. So this is what we want to go ahead and use. To get this ES2015 module syntax to work in the browser, we'll have to run our code through what's called a transpiler. So think of the words translation and compiling put together. So we need to compile our code, but first we actually have to translate it into a slightly different version. Essentially what we're going to do is take code that we're going to write using ES2015, any features from ES2016 or ES2017 that we may use, and actually translate this into something that all browsers can understand. We're going to translate it into ES5, essentially. So the tool we're going to use to do that is called Babel. I have the Babel site up here, and we see on the left-hand side we can kind of type in ES2015 code. On the right-hand side, it's showing us what this gets transpiled into. So we see when I use const, it's actually turning it into a variable. We're in strict mode, and it knows that the variable shouldn't be changed. When I write an ES2015 class, it's actually turning it into this constructor function, adding methods to the prototype, and not using any of the kind of ES6 syntax that different browsers may or may not support. So we're going to need to tell Webpack to use Babel. And so the first thing, we're going to have to install some packages here from Babel. And so you may think like we would say npm install -- save dev Babel. Babel is actually pretty modular as a library, and there's actually several different packages we have to install here. So we're going to install the Babel core library, the Babel loader library, and the Babel -preset -env package. Make sure you do the -- save dev, so we save this locally to our project. So I'm going to press enter and let those install. And I'll talk for a second about what those different libraries do. So the Babel loader package is about having Babel and Webpack talk to each other. It's going to it's just telling Webpack like, hey, you should use Babel. The Babel core is all about just like the kind of core functionality of Babel, which is take some code, do something to it, parse it in some way, and output it together to another file. The Babel preset env are the actual rules of how to parse that code, how to turn ES2015 into ES5. So each one of those libraries is doing its own kind of part of the job, and you could imagine, we're using the -preset rules, but there may be other rules we could use or whatever. So it's the package is broken up into these kind of like smaller packages. Great. So now that those are installed, let's go to our project, and we should see we actually need to, now we have those here. If we look at our package.json, we have all these Babel dependencies. We need to sort of tell Webpack in its configuration to go ahead and use Babel. So what I'm going to say is add a new key value pair. Don't forget the comma. I'm going to say module. This is going to point to an object. And in here, I'm going to have rules. We could imagine we're going to have like many rules for different things that Webpack should do. So this is actually going to be an array. We need to tell it the different rules. There's basically 2 keys we'll tell in every rule. We need to say use, and we tell it like what to use, and then we're going to say test, which is like what type of files to use this on. So we want to use the Babel loader, and in test we're going to actually give it a regular expression. Say, hey, don't run Babel loader on every file, just on an HTML file or CSS files, right? We want to only run the Babel loader on anything ending in JavaScript. So we need to say, we're going to do the regular expression, so we're going to two slashes. In between here, we're going to say escape the period and say .js, $, meaning anything ending in .js. So these are the rules. We're going to say use the Babel loader on anything that's ending in .js. Now remember, we have this other package called the Babel preset env, which we're like actually supplied the rules for saying here's how to turn ES 2015 into ES5. So we actually have to tell Babel to use those rules. So we need to put those rules in a file called .babelrc. So I'm going to go here, I'm going to say touch.babelrc, go to my project, and see that we generated this file. Inside of here, we're going to define an object with a key of presets pointing to an array of the presets we want to use. And we're going to go ahead and use the Babel preset env. Okay. So inside of index.js, we make calls to this API class as well as this animal class here. So right now, we don't have access to either of these variables, and our code is blowing up here because these are actually in other files. But I'm going to use the ES 2015 module syntax, which works conceptually very similarly to the common JS style we use of saying module.export and the require function, but we're going to use a slightly different syntax. We're going to say import animal from, again, a relative path, /animal, and I can leave off the .js at the end. I'm also going to import API from /API. So this is super cool. It's require statements in Ruby. You're going to say require this file, but you actually don't know, like I'm looking at your code, I don't know like what functions, what classes I got from where. This is making it super clear. It's saying, hey, when I see the animal class, I know that came from this file. When I see this variable, I got from this file. So we're importing specific variables from specific files. Now, we just need to go to those files and actually tell them what to export. So let's go here to our API. See, here's we have this class API, which has all these functions. What I would do is go at the bottom and say export default API. I can do the same thing on my animal class. I can say export default animal. Because this is just one thing, I could even, if I wanted to, say export default class of animal all right here, and I wouldn't need this at the bottom. This is just doing one thing. I'm going to keep this at the bottom just for consistency's sake, but either way it would work exactly the same. Okay, great. So we're going to run npm run build again. npm run build has the entry point set up in our Webpack config of this file. This file is going to go including those other files. So let's see what that generates for us. Great, we actually even see right here that several files were included in. Let's go take a look at our bundle.js. And now this actually has all of our code. It's doing all the stuff here. This is our index.js. I see here's our animal class kind of transpiled into this constructor function and all that stuff. Great. So now our index.html is serving up this one file, our build/bundle.js, and everything should work correctly. I'm going to go back to the browser, to our application, and refresh. Great. And now we're actually getting these animals back on the page, and we have the full kind of like functionality app. So this is super cool. It's more performant in that we're just loading in one file and not grabbing multiple files, as well as if the application grows and we can still have the nice like kind of way that our code is split up into multiple files for development and we know where to look, well, we can put it all together in one file, and we don't need to worry about the order of these dependencies or the order that we're including things into our script tags in our index.html file. So that's sort of how Webpack and Babel work together. Remember that Webpack's job is just basically to take a bunch of files and output them into one file. That's what we call our bundle. Babel's job is actually do the transpiling of taking code that is in ES 2015 and beyond and putting it into and translating into something that all browsers can understand. There's one more thing I want to talk about, which is the Webpack dev server. So we can imagine right now that if I want to make any changes to my code and I want to actually test them and go in development and see what that is going on, I would need to run this whole process again of running npm run build, which is going to make this new bundle, and I can test that code, and anytime I make those changes, I'm going to have to run npm run build. And that would be pretty annoying. We want that kind of quick feedback loop in seeing what the code we did changes. That's what the Webpack dev server is going to be able to do for us. It's going to give us sort of hot reloading. When we make changes, it's going to actually run the bundle and do that automatically for us. So let's do that in the next section. So let's go ahead and install the Webpack dev server. So npm install --save -dev webpack -dev -server. So while it's installing, let's talk about this term server, because it's a little bit confusing here. This is not a server in the sense of what we're used to is like our Rails servers, where our kind of like server-side logic goes of, when the route looks like a certain way, here's how to handle it, make requests to our database, and all that type of stuff. This is really just a server in the sense of that it's running, listening for changes made to our code. When we make changes to our code, it's going to recognize that change, and it's going to go ahead and like refresh the application. So to run the Webpack dev server, we're going to go ahead and add a script to our package.json. So let's run the start script, and this will run the command webpack -dev -server. Again, we could totally run this command from the terminal, but we want to be sure that we're running the specific version we specified in our, locally in this project, so we're going to make this script. All right. So there's one more change we have to make to get this to work correctly, and we'll talk about this in a second, is that let's go to our Webpack config, and let's add an additional property called the public path, and that should be called build/. Don't forget the comma there after file name. Okay, so I'm going to go to terminal. I'm going to run npm run start, and it's going to boot up the server. It's telling us there's a server running on this port, localhost 8080. So let's go ahead and copy that. Put this into our browser. I already have it up and running. Awesome. So here's all our code running as normal. It's running on a certain port in our computer rather than just us kind of like opening up an index.html file. What's really awesome about the Webpack dev server is that if I go ahead and make changes to my code, so let's go to animal.js, and instead of printing out that animal species, let's say they're all dogs. I'm going to save this file, go back to here, and we'll see this. I didn't even refresh the page, it's just automatically loaded. So this is really awesome for development because you'll make your changes and it'll just constantly kind of be up to date with all of your changes. One thing that's really interesting is right before this video, I actually deleted my build directory right here because what the development server is doing this all in memory. It's not actually creating your bundle and like sticking it into that file. That file doesn't even actually exist at the moment. Remember, we're still linking to it here in our index.html, which is why I need that public path. It's just the place that those assets will kind of be in memory so that this still works as expected. But we would really, when you're building a real application, you're only going to run that npm run build like kind of when you're done and like ready to go in production. In development, you're just running on this web development server, and it's all just kind of being stored in memory. Great, that's about all I wanted to cover for this topic. Just kind of at the end, I want to wrap up and kind of like put things in perspective just a little bit. The big takeaways from this talk are not to remember exactly how the Webpack configure is set up or what the heck this preset env option is here, but it's kind of the larger picture of we should have some understanding of like what Webpack's job is, right? It's to take a bunch of files and combine them together into a bundle into one file. Babel's job is a transpiler, and just to have some fluency in these terms, it's really important because this JavaScript ecosystem is complex. Like, this is kind of crazy. And how are you going to remember all this stuff? You're not. We're gonna use some like packages that have this stuff kind of set up for us. And I just want like some kind of like basic fluency in what these things are, and like not to be super intimidated by like understanding everything that's going on. You know, when you're doing the labs and you see that they're like, my code is now running on a server and we haven't really done that before in JavaScript. All that kind of is the stuff we've talked about here. I want to show you guys this article. This is from, like, I guess last year, How It Feels to Learn JavaScript in 2016. This is kind of a sort of controversial article. It kind of like is basically, it's saying the modern JavaScript ecosystem is crazy. You're using 7 different technologies to put hello world on the page, and it's like totally insane. And there was all sorts of kind of like you know, people agreeing with this article, and then people kind of like counterpoints to the article. And the truth is, like, this Webpack and Babel and stuff are like really complex tools, and they're doing a lot for you. And when it all works and everything is like working well, that's great. When stuff doesn't work and you got to kind of figure out the configuration going on, it can be like really difficult. We won't really be doing a ton of that here. I just wanted to give you guys some introduction to what these tools are, kind of have some like higher level understanding of what they do, and see that it is something, you know, if we do enough Googling and kind of like following along stuff, that we could sort of set up on our own. So those should be the real takeaways from this, and just so that when we move forward and look at React, we'll really be able to focus on the stuff about React and not focus on all the tooling around like how our React code is actually running. Great, that's about all I've got. Thank you. Bye.